So we started with this on our first day of logs, and I said you could do the circle of logs, and you could say, don't even write this, just listen. You could go log base 5, and then you bring it around here and say f24, and then you bring it around and it equals x. And that's the answer. And this is why logs are an exponent. Because see, that right there is the answer. That is the log, and that log is giving us this x, which is the exponent. So it's kind of a weird thought that logs, when you're done with a log and you have like log base 5 of 24, that's an exponent. Because see, there it is, it's that, and that's the exponent. All right, now, there's another way you could have done this. 5 to the power of x is equal to 24, and I'm just spreading it out so that I have room and I can put in a log on both sides. Now, remember me telling you the other day that you didn't have to have a base? Because if you don't have a base, what base do you really have? Base 10. Okay, good. Now, one more thing. When you put in a log on both sides, you get to pick any base you want. Base 10 isn't particularly nice in this problem, but base what would be? What base would be really smart to use on this log? Because it would all of a sudden make the answer way easier. 5, good call. Because, look at it now. Do you know that answer to that whole box? What's that whole box equal to? Not 1. X. That whole box is X. If you don't get Y, it might remind you, you could put that down in the front if you wanted to. So now, do you get that this whole side here is X? That whole thing is just X. And look, log base 5 of 24. So my point is that you can bring logs in on both sides of an equation if you want to. And you can use any base you want. All right, the next thing I got to talk about is base change. If I have log base 3 of 7, what base does it have right now? Base 3. What if I wanted it to be base 9 instead of base 3? Can I just times this by 2 and this by 2? No, that does not work. It is not that simple. If I wanted this to be base 9, everybody write this down, please. That is base 3. But it's equal to log with no base of 7 over log with no base of 3. Now, I said there's no base, but if there's no base, what's the base really? 10. But wait, there's more. These two are equal. You could type this into a calculator and you'd get some decimal. And if you type that in the calculator, you'd get the exact same decimal. Okay, so these are equal. But if you wanted, you could use any base you want. And so instead of log base 10, which I just did, and would go into a calculator really nice because there's a button called log on the calculator, which is going to do base 10. You could use any base you want. If you wanted it to base 3, you could. Now, I want you to process that for a second. Just think about that for a second. Log base 3 of 7 is equal to log base 3 of 7 over log base 3 of 3. That's weird, but it's true, isn't it? Because what's log base 3 of 3? Isn't that just 1? So then it's for sure true. You can see that it's for sure true if the base is 3. Don't you get that that's equal to 1 and then, yeah, must be true. So it isn't just 3, it could be anything. So I'm going to get rid of this 3 and I want it to be log base. Okay, what's one base you cannot use? 0 is not allowed. In fact, it has to be positive. So I can't use a negative. I can't use 0. And what other base can't I use? 1. Do you remember that? Base 1 is illegal. In case you forgot that. Can't use base 1. All right, so any other base than that? Like, could I use base E if I wanted to? You could. All right, so what the heck is E again? It's a number that's kind of like pi, goes on forever, never repeats. It's about 2.7. So I can use any base I want, so I choose that. And the cool part about this is there's a button on your calculator for that. Know what the button is? It's not log. All right, there's a button on the calculator called ln. So get used to seeing ln, which means log base e. You don't have to have a calculator. No point in taking the calculator out. You're not going to have a calculator on the test. But the point is that there's two kinds of logs that are a big deal. Plain old-fashioned log, which means base 10, because there's a button for it on your calculator. That's why I'm saying it's a big deal. And ln, which means log base e. And it's kind of a big deal because it's got a button on the calculator called ln. All right. So if you didn't know that, if I never told you what log on the calculator means, like what does that button do? It does log base 10. And if I never told you what ln was, that'd be pretty sad. That means log base e. All right. Try to remember that if there's no base, you'll find it's all about the base, just like Megan Trainor said. So if this is ln of 5, you should be able to go, okay, this is a little confusing because there's no base on that. So I'm going to fix that, and I'm going to make sure there is a base. So you would, please write this one down. You would replace the ln with, what did I say that was the same as? Log base e. And if you write that instead, if you actually go, I'm not going to use ln, I'm going to use log base e, then doesn't the answer become much easier? I would say obvious. Do you get that this answer's 5? It's one of those deals where, oh, the bases are the same. So the answer's already there. The answer's 5. So many little patterns you have to know. Like if I put a log base 5 of 1 here, you're supposed to know the answer. Like that, what's the answer? You won the argument, you get 0. Good. If I put a 1/5 here, you're supposed to go, oh, I could make that a 5 to the power of, what's the answer to this one? -1, good. Because that's the same as 5 to the -1. All right. I think the hardest ones for you guys are these. Log base 5 of the cube root of 5 but squared. And I know the answer to that. Do you know the answer to that? If you can get the bases to be the same, if they both could be base 5, then it'd be easy. And I think that's the problem, is that a lot of people still haven't processed how to make that into 5 to a power. That's 5 to a power. Brooklyn, what do you think it is? 5 to the what? It's either the 2/3 or the 3/2. Now think it through carefully. Don't just guess one because it's 50-50. It's either to the 2/3 or the 3/2. Hint, the root goes on the bottom, just like in plants. It is to the 2/3. Good. This means 5 to the 2/3. The root goes on the bottom, just like in plants. And now that I did that, I hope that it means the answer is obvious to you. It's 2/3. Okay, another skill we've learned. There's so many different things, all that you have to know all at the same time, is if you have logs that have the same base as each other, like log base x of y, log base x of 2. Wait, this has got to be a plus or a minus, not an equals, that's for sure. I'm going to say minus. If you have two logs that have the same base, then you can rewrite it as one log. And I gave you a bold statement. Just like if you can factor it, you should. If you can combine them, you should. Because it makes the problem easier. So I'm going to finish this problem with equals 1. And I'd like you to solve it. We'll solve it for what? There's x and there's y. I want you to solve it for y. As in, try to get the y alone. This is hard solving, and that's what today's lesson is about. Today's lesson is about problems that are hard to solve. Why is this one hard to solve? Well, first of all, you got to combine those two logs. Second of all, you got to know how to rewrite this thing so that it's not a log anymore. And then you got to know how to get the y alone. You could solve for x or you could solve for y. I asked you to solve for y. All right, that is not easy. In a moment, I'm going to ask you to compare with the kid next to you, and maybe you got stuck at different places. Maybe you both got the answer. I don't know. I'm going to pause for a second, wait till they're done, and then compare with them. All right, let's see if you work through this tough one. You should have known to combine them into one log. And what would its base have to be? X. And then if you have a minus, you take this, and you would divide them. Y over 2. In that order, it does matter. Equals 1. And now, if you rewrite this puppy, the circle of logs just keeps coming back. It's such a big deal. X to the 1 is x equals, and then it's y over 2. And then it's not that hard, is it? Times by 2 on both sides. Y equals 2x. Raise your hand if you had that one right. Sweet. Okay. Now, what happens when you're in the middle of a normal-looking solve problem and all of a sudden there's a quadratic and you end up with this? Do you remember how to solve that? Because after you did a bunch of work and the logs dropped out and all of a sudden you've got this. Do you remember how to solve it? I remember how to solve it. The question is, do you remember how to solve it? Copy it down. Step 2. Who knows what you do to both sides first? Subtract 4 is correct. And if you're doing the quadratic formula, I love the thought, but there's a way faster way. What is the faster way? Factor it. Because if you can factor it, you should. It's just so much easier. I mean, I like the quadratic formula way. It's just that it's got 16 parts to the formula. And I can solve this in x and a plus and a minus, and it's got to be a 4 and a 1, and then I get two answers, x equals -1 and x equals 4. Except you're wrong. Why? Did you even take a second to check and see if they would actually work? In the original problem, there would have been a log, right? Do you get that it's very likely that one of those answers would have made a base or an argument negative? Don't forget to check that stuff. That's going to happen on your next test. Extremely likely that one of your answers that you have might not work. Because what if the original problem was log base 2, don't even write this down, of x, let me think, plus 1. And let's say that was in the problem, and there's more to the problem. Do you get as soon as you put in -1 right here, you'd have a log base 2 of 0, which doesn't even exist? All right, so watch out. Watch out, watch out. You get your answers, you can't trust them. Got to go back and check them in the problem. All right, so I have already well prepared you for this, other than the quadratics part, which you're just not going to like very much. I'd like to do one of your actual homework problems with you. So this is not going to be the first problem of the homework. So don't even open the homework yet. Just write this down and keep it, because it'll help you on problem 10. Log base 8 of 16x plus log base 8 of 4x squared is equal to log base 8 of 27. Now you might think you could just cancel all the logs out. No, you can't. Doesn't work that way. But you can condense these two, and then if the log bases are the same, you can take them out on both sides, but not until you condense these two. Get it down to one log. I got to take this and multiply them, because it's add. It's add in the middle, so it must be multiply them. Anybody know what 16 times 4 is? 64. X to the third equals log base 8 of 27. What do you guys think I should do next? Yep. It's not really canceling the logs, but it's saying this has to equal this, so let's focus on those. And then would you be able to solve it? I would. I would hope you would. What would you do to both sides? Divide 64. And I really wish that this was reduced, so I guess I would reduce it. And then put it to the power of 1/3. Does 1/3 power cause you to get two answers? No, but what if it had been 1/2 on both sides? Yeah, you'd have two answers. Watch out for that. It's going to happen, for sure. It's going to happen on your homework, too. All right, this is problem 10 off your Schoology quiz for today, and it's mostly done. If you can finish it from there, you'll have problem 10. You just got to get X alone. And you might be like, well, I don't know how to find the 1/3 power of that. Actually, if you do the 1/3 power, you could do it in your head right now. Because you probably know the third root of 27 if you really think about it. And you probably know the third root of 64 if you really think about it. It really wouldn't be that hard without a calculator to get this. All right, so there's a typical hard problem that you have to do for today. The whole point is called solving. I'm going to give you a bunch of time, and you can ask me questions. It is a Schoology quiz. And I always set my Schoology quizzes so that you have 2 tries and you get the answers after the first try, but you get the average of your 2 scores. Average of the scores prevents kids from just putting crap answers in to see what the answers are, right? Otherwise, if you average a 0 and a perfect paper, you get a 50%. You wouldn't want that, right? So try on your first try and see the answers. I think it's the best that I can do, best of both worlds. All right, so go ahead and open up that Schoology quiz. We'll do problem 1 together. Log base 4. Sommerfeld, would you read me the rest of problem 1?
Mine is log base 64.
Okay, hold on just a second. I don't know why mine would be different than yours. Okay, I just read it wrong. Thank you. Log base 64. I'm just going to copy from here and I got it. X minus 7 and then equals 1/3. Is that what you got? Okay, good. All right. So the number one thing you're going to use on this next test is the circle of logs. You just got to keep coming back to that one. It isn't always the answer, but if I was ever stuck on a problem, just like on most of this class, factoring is the answer. There's even some factoring on this next test, but this comes up the most. If you get stuck, try rewriting and see if it works. And then things like 64 to the 1/3 is something you should just memorize. You guys know that one? 4, because 4 times 4 times 4 is 64. And then the whole point is just get X alone, so add 7 and you're done. All right. Okay. I think you were pretty well prepared. We've done a lot of stuff on logs like this before. So I know these are not easy, but I think you have all the tools that you need. So you have a bunch of work time. You have kids next to you that have the same questions as you. It's totally okay to be working together. And that's all I got for you for today.